Hello everybody, now we are going to solve a problem from Fundamentals of Electric Circuits by Alexander and Sadiku 6th edition. So it is a cascade amplifier of op amp. So we have two stages of op amp here and the problem number is 5.54. Okay, now let's get started to solve this problem. Look at this problem. Here this is your input and you have R values available with 10 kilo ohm, and this is the output of the first stage and this is the output of the final stage, and the output is V naught, and we are asked to find out the voltage transfer ratio V naught by Vi. So whenever we don't have any clue about how to solve these problems, the basic and the most fundamental thing is to apply KCL, Kirchhoff's current law. It states that in a particular node the summation of incoming currents is equal to summation of the leaving currents. So now we are going to apply this concept here at this particular node. So here this node is at ground potential, right? This is grounded, so it is at zero potential, means this is also at zero potential. Let's name this as node number 1, and this node 1 is at zero potential, and for this node 1 we are going to apply KCL. Okay, so we'll mark the currents here. So let's name this as I1 current, this be I2, and this is I3. So this I1 is flowing from this Vs potential to V1 potential, where V1 is, already I have told you that it is at zero potential, 0 volts. Similarly, we should know the value of this. Okay, so we'll mark this as node number 2 with V2 potential. So the same thing reflects here according to ideal condition. Okay, so we should know what is the value of this V2. So V2 will be equal to, when you look at this, when you refer this is your V0 value. So here we can apply potential divider rule to find out this V2. So this would be equal to V0 multiplied by this R divided by R plus R, right? Here you have R, here also you have R, so R plus R is 2R. So you can cancel it out. So it is equal to V0 by 2. So with this, we can now proceed to find out, or we can apply this KCL at node 1. So the incoming current to this node 1 is I1 and the leaving currents are I2 and I3. So here we can apply Ohm's law. So what is I1? I1 is Vs minus the zero potential or the V1 potential, right? 0. Vs minus V1, that is 0, divided by the resistor values are, that is equal to I2. I2 current is flowing from this V1 potential to V2 potential, so 0 minus V2, so minus V2 divided by R, plus I3 is also flowing from this V1 to this V0. Okay, so it is 0 minus V0 divided by R. So everywhere you have this R common, so you can cancel it out. So now you have this Vs is equal to minus V2 plus, sorry, minus V0. And we know this V2 is equal to V0 by 2, isn't it? So you can substitute it as V0 by 2 minus V0, that is Vs. So Vs is equal to minus 3 by 2 V0. But in the problem we are asked to find out this V0 by Vs. So V0 by Vs is equal to, so V0 by Vs equal to minus 2 by. So this is our answer. This is the voltage transfer ratio. Thank you. Hope you have understood.